Hello guys, welcome to my page. Again, this is Mr. Technician. I will discuss today the power control. Actually, the power control has three stages. So first is the power control, which is the normal one, and the second is the total power control, or sometimes they call summation power control. This summation power control is both pumps acting on the power piston. So both pressures from front and rear acting on power piston. And then the power shift control is from control proportional solenoid or pressure reducing valve. This is the pressure is either proportional or inversely proportional to your milliamps. So I will also discuss that, but today I will only discuss the power control, which is the normal one. Okay, so again, the power control is a function of the load. Okay, it's not the result, direct result of an operator control, but it is a function of the load that is acting on the pump. Okay, so that's the power control. Okay, by the way, power control is not really the right term. The right term is a torque limit control. Okay, so torque, then limit. Okay, control. So we're limiting the control of the torque of the engine so that the engine will not stall. Okay, so that is the right term really when we look on the PQ diagram or curve. So it's actually a torque limit control. So this is the power lever. If you see on the K3V, the small lever is a power control. The longer one is the flow control. So if this is the longer one, this is the flow control, and this is the power control. So this one here, this pin here is actually connected to the on your communicating spool. So that one. Okay, so this spool here is shift or moved by the power piston. So the power piston is this one. So that one. Okay, so this is the communicating spool and this is the power piston. This is the power piston. Okay, so this power lever here, this is the, so if we draw that, okay, and you have the outer spring and you have the inner spring. Okay, these are the power springs. So you have the outer, the big one, and the small one is the inner spring. Against that, there is a power piston. So this is your power piston. Then the force here is your pressure times area. This is the pressure from your pump, okay, which is created by the load. Okay, now the spring, you have the spring stroke, okay, times spring rate outer. This is the outer spring rate. Okay, that's the force of the, and the inner is same stroke, spring stroke, and this one is outer and inner. Outer plus inner spring rate. Okay, Now, as a result, the area, the area times pressure is equal to stroke times spring rate, because that is your force. So that's the result. So meaning, guys, the pump delivery pressure is proportional to your spring stroke. Okay, so the delivery pressure, so remember guys, this is your free length of spring. Okay, and when there is a load, that is your deflection. So again, when there is a pressure, so it proportional to your spring stroke. Okay, so let's put a graph here. This is your pressure, and then spring stroke. So the graph will be like that, and so this is the outer spring, and this is the inner spring. Now, why sometimes not sometimes, but why is it two spring? Okay, two spring because to match the true power curve. So in theoretical, the power curve is like that. Okay, sorry, it's like that. So to match that curve, you need two spring. Okay, so to match the true power curve. So remember that. So the pressure is proportional to your spring stroke. Okay, so that's the principle. So in the circuit, guys, the pump itself, so when the pump displacement in the power control is changed due to load. Okay, so and the load is, or the pressure is proportional to your spring stroke. So let's apply that principle to the circuit. Let's do a circuit. This time we'll do one pump only because I will explain only the power control. Okay, so this is your large piston area, and this is your small piston area. So this way here is when the stroke spool move to the left, means the pump displacement is going to max. When it goes to the right, is going to minimum. Alright, and then in here, this is your control gallery. Okay, now this is your feedback lever, which is this one. This one is the feedback lever. Okay.
So here is auto.
This guys, this spool here and sleeve is, this is the one. Okay, so that's case drain. Okay, now this is your power lever. Okay, outer spring, inner spring. Okay, and then you have your power piston. Okay, right. So when this move, it will minimum, so meaning will go like that. So make common this one. Okay, check valve. One there, okay, and there's another there for your servo, but we don't include that one. So this one move, and this one, okay, this one will close, and the other way, this one will drain, this one close. Okay, so this one is okay. Alright, so let's simplify the circuit. I just need to explain this thing here. So this is your power control here. This one is the sleeve. So see this hole. This is your pump pressure acting here, and this is for your from your second pump. Okay, so this sleeve here is a summation. This is a multi-line sleeve, so this is a summation type because it has two holes, two gallery. Okay, so this time I will only explain this power control. Okay, this is the power piston, so meaning this pressure here, this pump pressure is acting on this area, this end. Okay, so meaning if there is a delivery pressure, when the delivery pressure is increased. Okay, so let's put a red. Check valve will open, and the delivery pressure also, that pressure also acting on here, and this will become red. Okay, and here, okay, so this will become red. So when the load increase, the pressure will increase. Okay, remember, pressure is force over area. When the load increase, the pressure increase. Okay. All right, now this two spring here is set from your power curve. Okay, your PQ diagram. This here. So remember, the pressure that act here is proportional to your spring stroke. Okay, so let's do the PQ curve, so that we will apply the PQ curve in this control. Okay, so how that works, so this is the sleeve, by the way. Okay, all right. Alright, so this one will not move unless this one will move. Okay, so see, it's close. Alright, so let's discuss the PQ curve, and then let's apply the PQ curve in this control. How the pump responds. Okay, remember the power curve, the power control is a function of a load acting on a pump. Okay, so power control is a function of the load that is acting on the pump. Okay.